am Kim Jake Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us, science, nature, and technology. The first surprise is how we're telling you our stories. Get ready for a fun, fast-paced tour of short little video bits. Each one promises something new, from news on the hottest fires to the world's longest bridge, plus comparing our sun to a beach ball. No, really. But first, you've heard of occupational hazards, right? Well, these occupations are hazards.
Work bothering you lately? Time for a reality check. There are some deadly jobs out there, ones that give new meaning to the words occupational hazard. To shipbreakers in Bangladesh, hazards are a way of life. They take apart giant freighters and five-star ocean liners by hand, vessels the size of apartment blocks, 10 stories high. When a ship comes here to die, first on the scene are gas cutters, operational infantry who attack the steel hull with gas torches, reducing it to multi-ton pieces. Another crew then reduces these chunks into pieces the size of a school bus. Finally, porters step in.
One, two, three.
Human cranes shouldering the full weight of the ship, lugging the plates into trucks to be hauled away. Keeping the operation going means men working 7 days a week in temperatures hovering at 50 degrees Celsius. Uncomfortable? Sure, but not nearly as hot as an erupting volcano. Ask any volcanologist, the brave souls who predict when volcanoes will erupt. It's important work. 1 in 10 people live within range of an active volcano, and they can go off without warning. Volcanologists make predictions based on the pattern of the smoke and movement of magma. To get a front row view, they chopper over the crater. Some don't return from the journey. No surprise, explosions can hurl ash and hot rock at hurricane speeds, kilometers into the air, enough to take out commercial aircraft. In 1982, a 747 flew into a plume of volcanic ash from Indonesia's Mount Galunggung. All 4 engines failed. Luckily, the pilots were able to find their way out and restart them. There have been dozens of similar incidents. Smoke jumpers know a thing or two about taking heat at work. The world's most elite firefighters routinely dive into 400-hectare blazes from rickety aircraft, aiming for spots no bigger than a baseball diamond, surrounded in tall timber, wearing 30 kilos of protective gear. At least the Kevlar suit eliminates the risk of getting stabbed by a tree branch on the way down. Fully suited, they would be impervious to the blows of a baseball bat. Off the coast of Louisiana are oil rigs, dangerous by their own right, but travel 60 meters down into the murky depths of the Gulf of Mexico, and you'll see some real danger. This is the workplace of the hell diver, a specialized angler who hunts sturgeon the size of horses. They graze here on this man-made reef, a 3-acre maze of legs and crossbeams. The hell diver hunts here with a spear gun. But if the fish survives the initial assault, he's going for a ride. Like a bull rider getting bounced against the corral barrier, he holds on for dear life in this underwater rodeo. Even the dive itself is dangerous. Here, Martini's law prevails. That's the rule that says every 15 meters of depth equals the effects of 1 dry martini on the human brain. That's a 4-martini dip. It gets worse. At those depths, oxygen can actually become toxic to the central nervous system, causing blackouts, hysteria, and convulsions. Pretty grim things in your living room. Imagine it at the depths of the Gulf. And here you thought your job was killing you.
I think my job is pretty safe by comparison. When we think of dangerous jobs, we think of firefighters, right? Starting a fire is pretty easy, but putting it out, well, that's a whole different story, especially one that's been burning for thousands of years.
Each time we watch a fire blaze out of control, we are reminded of the basic rules of fire. It likes oxygen, wood, and usually extinguishes underwater. But sometimes fire doesn't play by the rules. Take a deep breath. Before the 2002 Sydney Games, the Olympic flame was taken on its first underwater journey at the Great Barrier Reef and kept on burning. That was because a formula of chemicals, including combustible magnesium powder, produced enough oxygen and nitrogen to burn the flame at 2,000 degrees Celsius. Instead of collapsing under the water pressure, the flare generates enough outward force to keep the water from entering the tube. Sometimes no amount of water can stop a fire. In June 1969, Cleveland, Ohio's Cuyahoga River ignited. Oil slicks and industrial runoff from local factories caught fire on top of the water. 5-story-high flames burned for 30 minutes until firefighters squelched them. For years, Cleveland had a hard time outliving its environmental disaster reputation as the mistake on the lake. But other unexpected places also burn without kindling, like piles of tires. In Hagersville, Ontario, a fire started in a pile of 14 million car tires. In 1990, they burned for 17 days and nearly forced 4,000 people to evacuate. A single tire contains about the equivalent of 7.5 liters of oil. In this fire, that would have been 105 million liters of oil, enough to fill 42 Olympic-sized pools. In order for a car tire to catch fire, it needs to be heated for at least 20 minutes at 400 degrees Celsius. And putting out tire fires is extremely difficult. Water won't work. It just produces a slick, oily sludge. Smothering the burning tires with soil or sand is the best option. The longest burning tire fire blazed for 2.5 years, from August 1998 until December 2000. The fire ended up torching 7 million tires at a dump in Tracy, California. Other fires hang on even longer. The former coal mining town of Centralia, Pennsylvania literally sits on a hot plate. Started by burning trash in a mine 45 years ago, the coal seams are burning 100 meters underground. Constant access to oxygen through caves and rock fissures keep the embers smoldering. Need a cup of tea? The groundwater in that town is over 100 degrees Celsius in places. It's like living over a volcano. No surprise, most of the town finally accepted a government buyout in the 1980s and left. The fires are expected to last another 250 years. But if you think that's a long burner, try this. 300 kilometers north of Sydney, Australia, scientists believe a huge coal seam has been burning for 6,000 years. Known as Burning Mountain, it's the oldest known coal fire in the world. 19th century explorers mistook the sulfurous smoke as a volcano. When the ground you walk on turns out to be like a giant charcoal barbecue, you need to rethink what can burn and where a fire can't go. Maybe this ought to be a new fire prevention rule. Wherever, whenever, always carry a portable fire extinguisher.
Who knew all those fires were burning underneath us? Next up, from fires to the wettest hotel on the planet. See you in a bit. Welcome back to Cooler Facts. How do bridges stay up? Here I am, suspended 40 feet above an urban highway, standing on tons of concrete. But again, I ask you, how do these things stay up?
The world's longest bridge extends 38.4 kilometers across Louisiana's Lake Pontchartrain. The conventional bridge is made of 9,500 steel pilings supporting concrete spans that are collectively longer than Long Island. But the truth is, some shorter bridges pose much bigger engineering challenges. Like spanning across an earthquake zone in water up to 65 meters deep on a seabed of loose sediment. That's why the 2,880-meter Rion and Tyrion Bridges piers are sitting on top of leveled gravel reinforced by steel pipes rather than buried deep into the ground. When the earth shakes, the piers move side to side and absorb the seismic energy. If you're worried about shaking, you might not want to peek through a glass-floored skywalk that sticks 20 meters out and hangs 1,200 meters over the Grand Canyon. Built 14.5 meters into the rock, the horseshoe-shaped walkway contains 455 tons of steel, cantilevered to sustain the weight of 71 fully loaded Boeing 747s and the force of an 8.0 magnitude earthquake within 80 kilometers. Can you imagine a plastic bridge? Well, it already exists. A 2001 California highway bridge is made of carbon fiber composite tubes encased in plastic and a deck of fiberglass panels instead of steel girders and reinforced concrete. The girders are light enough that 4 men can manage what normally requires a construction crane. And without steel, subject to corrosion, the bridge is less susceptible to damage from salt and water. Sometimes it's not just the traffic that moves. Some bridges do too. But the Gateshead Millennium Bridge in Newcastle, England moves differently than your standard drawbridge. A bank of 6 hydraulic rams tilts the entire 773-ton steel structure 40 degrees, so large ships can pass under it in just 4 minutes. Maybe the most daring engineering is to imagine a bridge in one of the most hostile environments, across the Bering Strait. This proposed 80-kilometer Arctic super bridge would span more than twice the length of the Lake Pontchartrain Causeway. Construction challenges include working in sub-zero temperatures and sustaining hits from ice flows. A design already exists for ice flow-resistant bridge pylons. They're shaped like the prow of an icebreaker. The biggest obstacle for this bridge is the price tag, an estimated $100 billion US. But the prospect of Russian oil piping across Siberia to the hungry US market might make this project happen. And with new engineering advances and gas prices, we may cross that bridge sooner than you think.
Okay, now I feel a bit better about bridges. But big buildings? Well, that's another matter, especially the one you can fly a jet through.
Architects and builders have been pushing the limits for centuries. Some of the world's most amazing buildings are built out of experimental materials and in the oddest of places. China's Central Television Network's new Beijing headquarters consist of 2 leaning towers that bend 90 degrees at the top to form a continuous tube. The 30-story high hull of this gigantic steel and glass donut is big enough to fly a Learjet through. The office floor space for 10,000 people is second only in size to the world's largest building, the U.S. Pentagon. The Jubilee Church that opened in Rome in 2003 is made of a special concrete that does not discolor. It not only cleans itself, it also cleans the air by eating surrounding smog. It contains titanium dioxide that triggers a chemical reaction that accelerates oxidation, destroying air pollutants. In New Mexico, there are Hobbit-style pods called Earth ships made from old tires and pop bottles. They survive entirely off the electrical and water grids. The home gets water from rain that collects on the roof. Whatever is used for dishes gets siphoned through a filter of gravel and plant roots. Then it's used again in the bathroom. Considering that the average U.S. household drinks, flushes, and washes about 482,000 liters of water a year, enough to fill over 3,000 bathtubs, these Earth ships are seriously self-sustaining. The Great Mosque of Djenné in Mali is the largest mud brick or adobe building in the world, with a base 40 by 40 meters, about half a football field. It's been the site of a mosque since 1240, but the current version dates from 1907. In the world of experimental architecture, Dubai is the promised land. And when the sky's the limit, go for a swim. Take a look at Hydropolis, promised to be the world's first luxury underwater hotel, to be 20 meters under the Red Sea. This $500 million resort will feature lavish suites, a ballroom, a shopping mall, and a missile defense system to ward off terrorists. To date, it's only on the drawing boards, so don't hold your breath. After all, there are already many other extreme buildings to visit.
An underwater hotel? Only in Dubai. Stick around right after the break. With robots on the cutting edge of science, why model one after a lobster? More cooler facts heading your way. Welcome back to Cooler Facts, where we present science and technology with a little twist and a bit of a surprise. I'm Kim Jake Tiani. Robots are on the cutting edge of science, but today's robots don't look anything like R2-D2.
For decades now, we've been dreaming of walking and talking robots, androids to help vacuum or make dinner. Well, robots have arrived, just not in the shape or places you'd expect. At Harvard University, they have invented a robotic fly the size of a penny. The Robo-fly weighs 60 milligrams, the same as a few grains of rice. A tiny motor beats its wings 120 times per second. The force is 5 times more powerful by weight than the muscles of a real fly. In the future, these tiny flyers will conduct surveillance on the battlefield. The U.S. military already has 4,000 reconnaissance robots scouting for roadside bombs and hunting down insurgent hideouts in Afghanistan. That's the same as 1 robot for every 10 human soldiers over there. In New York, robot takes on a new meaning at this parking garage. It works like a giant robotic jukebox. When you drop off your car, laser and radar sensors confirm the passengers are gone. Elevators whisk the cars away and stack them like pop cans several cars deep. To retrieve the car, swipe a card and the system delivers it in less than 2.5 minutes. That's faster than any valet. Plus, no tip required. Inside the human body, this tiny caterpillar-sized robot will soon help surgeons repair human hearts. Once inserted through a tiny keyhole incision, the robot uses its sucker-like feet to crawl over the heart's surface to position pacemaker leads or inject dyes. Mother Nature is a great inspiration for robotics. That's why scientists turned to the amazing lobster. Turns out they have an incredible ability to sense minute odors in the sea and hunt them down. So, engineers built the Robo-lobster, a 2 kilogram, 60 centimeter long robot underwater bloodhound. Instead of getting dipped in butter, it uses fiber optic antenna to sniff out hidden mines or locate the source of pollutants leaching into the water. Even humans can use a hard outer skin. Consider the U.S. military's plans to muscle up soldiers. Wearing this robotic exoskeleton, a soldier can carry ammunition boxes the weight of bags of concrete without getting tired. A consumer version is in production for Japan's aging population. The 15-kilo battery-powered HAL-5 responds to electrical impulses on the operator's skin and converts them into instructions to the suit. The cyborg has arrived.
Imagine having a pet robot named Spot. Robots should be able to work for us for an entire lifetime, but they can't hold a candle compared to our sun. It's been doing its job for over 5 billion years, and it's only just reached middle age. More cool facts about our sun and the stars around us when we come back. Welcome back. Who's your favorite Hollywood star? Julia Roberts? Harrison Ford? Mine's right up there. And here's something even the tabloids don't know about my favorite star, the sun.
The life of a star is so violent, so enormous, it staggers the imagination. Our sun, the star closest to us, is no exception. Its raw material is so powerful, just a pinhead's worth could kill someone at a distance of 160 meters. Its visible surface is a fierce churning cauldron of billions of furnace-like cells called granules, each one a kilometer in size. Granules explode, spewing their material into the solar atmosphere at 1,600 kilometers per hour. That's like rocketing over 10 football fields in a second. It's an outrageous understatement to say the sun is hot. The surface is 6,000 degrees Celsius, rising to over 15 million degrees at the core. The enormity of its heat output is mind-boggling. 400 trillion watts. That's 40,000 watts of light from every square inch of its surface. the brightness of 700 standard household bulbs emanating from an area the size of a quarter. Pretty breathtaking when you consider the sun's actual size, 1.4 million kilometers in diameter, 330 times larger than Earth. If it were the size of a beach ball, the Earth would be a pea. And that's just one star amid more than 100 billion in the Milky Way. Next to some other stars, the sun is downright puny. Betelgeuse, one of the stars in the Orion Belt, is a staggering 500 million kilometers in diameter. If it were hollow, the Earth would comfortably revolve around the sun inside it. Alpha Centauri, the nearest star visible by the naked eye, is 4.5 light years away. It would take almost 5 years to get there. If our sun were scaled down to the size of a period on a printed page, Alpha Centauri would be about 14 kilometers away. Because it works so hard, the sun will eventually burn out. The sun's been doing its thing for about 5 billion years. It'll probably do it for another 5 billion. At the end of its life, the star that nurtured us for so long will care little for us. The solar wind will become a cyclone that may even evaporate the atmosphere. The sun, as other stars have done, will explode into a supernova, eventually spinning itself into a neutron star. There is a bright side. The heat from the sun dying may be warm enough to melt the water-rich but frozen moons of Jupiter and Saturn. We humans, if we're still around, might relocate there.
And I thought moving from India to Canada was a big move. Well, that's it for this edition of Cooler Facts, the show that presents a different twist on everything from the coldest place on Earth to the animal with the deadliest bite. I'm Kim Tiani. Catch you next time for more Cooler Facts. Hi, I'm Kim Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us. Science, technology, and nature. The first surprise is how we're telling you our stories. Get ready for a fun, fast-paced tour of short little video bits. Each one will leave you with something new. From an insect that puts skunks to shame, to a surprising place on Earth that hasn't seen rain in over 2 million years. Plus, the fastest things on the planet. But first, an animal with the deadliest bite on Earth.
Just about every animal under the sun has teeth, but some bites are a whole lot scarier than others. Consider the African lion. It has a fearsome bite PSI force, that's bite per pound square inch force. It's calculated based on the size of the animal's mouth. The lion's is estimated at over 4,000 pounds. That's like having a 4x4 resting on the top of the tooth as it penetrates the flesh. Its canine teeth are spaced in a way that they can slip between the cervical vertebrae of their prey and sever the spinal cord. Their back teeth, or carnassials, work like a pair of scissors, cutting through skin and tendon. Unlike humans, its jaw cannot move side to side, which helps it get through flesh even more efficiently. And they're fast. A lion can accelerate to a speed of 60 kilometers per hour in less than a minute. Its tongue can also do major damage. It's covered in hard, spiny papillae, dense mounds of skin cells that begin the digestion process. With a surface as rough as sandpaper, a lion's tongue can separate meat from bones. It can also draw blood with a single lick. Inside a lion's stomach, its gastric juices have the same pH as battery acid, so the king of the jungle doesn't have to chew before it swallows. A great white shark doesn't waste a lot of time chewing either. Its bite is so big, it can take in almost 15 kilos of flesh in one chomp. And like most toothy predators, the shark has other tools in its arsenal to add insult to injury, like its awesome sense of smell. So precise, it can detect a single drop of blood in an Olympic-sized pool full of water. That's because sharks devote a huge part of their brain to powers of smell. And that's not all. Sharks also have sensory pores on their heads called ampullae of Lorenzini. These detect the electrical fields of prey, sensing an animal's heartbeat from a meter. Then there's the cougar. It has a bite so powerful it can bring down a small horse and drag it the length of a football field. We know the king cobra has some scary fangs, sharp enough to penetrate flesh like a hypodermic needle. It's what comes out of those fangs that's really unnerving: venom. And this snake can deliver enough in one bite to kill an elephant, or 20 people. Snake venom is actually a modified saliva. It comes from glands situated on each side of the head below and behind the eye. Muscles attached to these reservoirs force the venom through the snake's tubular fangs. Venom contains neurotoxins, deadly proteins that play a key role in immobilizing prey by causing disorientation, paralyzing the animal, and slowing its breathing. When in attack mode, the cobra sprays twin jets of deadly poison as far as 2 meters. No surprise that the folks who handle them wear goggles. The Komodo dragon's teeth are scary all on their own. Big, curved, and serrated like a bread knife, they rip through flesh with ease. And if its teeth don't do the job, its saliva will. Should an animal manage to escape an attack, the dragon's spit contains bacteria that cause an infection that will probably kill it within a week. Thus weakened, other dragons will move in on this easy prey. One of the most vicious bites in nature belongs to the Tasmanian devil. Uninterrupted, devils can eat up to 40% of their body weight in half an hour. Its powerful jaws and teeth allow it to completely devour its prey, bones, fur, and all. Terrifying? Absolutely. But still not the deadliest bite in the animal kingdom. That dubious honor belongs to a creature that kills some 2 million people a year. One that can drink twice its weight in blood. It wreaks havoc by transmitting killer malaria parasites to its victim. That, of course, would be the tiny mosquito.
I'll tell you one thing, I hate mosquitoes. But I have a lot more respect for bugs, especially after I heard about the bombardier beetle.
Who is really taking over the Earth? With 1 million known species and at least 6 million more to name, insects are the most diverse group of animals on the Earth. The secret to their success? Insects have developed the most ingenious traits to survive. It's exactly why you don't want them for house guests. Take the bombardier beetle. Like most beetles, it's vulnerable to attack because it can't open its wings quickly. So it needs an effective defense mechanism. The bombardier has a deadly ability to spray 700 rounds of acid per second in different directions from its butt. Sound like science fiction? Glands in its abdomen produce boiling hot formic acid at 100 degrees Celsius. Makes a skunk look like a lightweight. There's a way to compare insect stings. U.S. entomologist Justin O. Schmidt has invented a sting index from 0 to 4. At 0, a sweat bee's gentle tingle barely registers, but a yellow jacket's burning sting rates a 2. The chart topper is the bullet ant. At over 4.0, this nasty insect from the rainforests of Nicaragua to Paraguay delivers a paralyzing sting of intense pain. It's like walking over flaming charcoal with a 3-inch rusty nail in your heel. Sometimes even a bite isn't needed to kill. A millipede produces a stench powerful enough to kill a mouse. Its stink glands unleash lethal fluids that contain chlorine and hydrogen cyanide, and they protect their own. Millipedes use the same noxious fluids to cover their eggs and protect them against predators. Other insects have more than 1,000 legs to worry about, like the termite queen. A prolific baby maker, she can give birth to over 30,000 offspring a day. Survival by numbers. And she is not as prolific as the aphid. Almost all aphids are female, but don't even bother with sex to reproduce. Many are born pregnant. It's mind-blowing, but if all aphids were to survive, there would be 10 to the power of 27. That's 27 zeros. enough to cover the United States 4.5 meters deep in aphids. Other insects endure because they can find each other to mate. The male moth's nerve cells can detect minute amounts of female pheromone over 9 kilometers upwind. Like a bionic bloodhound, the moth zigzags across the wind as he tracks the plume of chemicals. Other insects use their keen perception to find a safe place to lay eggs. The melanophila beetle has discovered that a fire is a hot commodity. While a healthy pine tree's natural chemicals will poison the beetle larvae or drown them in sticky resin, a fire-damaged tree lacks those natural defenses. This beetle has evolved special organs under its armpits that act as ultraviolet light detectors. Against the tide of the escaping animals, the beetle radars in on a forest fire and finds a vulnerable tree to burrow in and lay its eggs. Given the ways they've adapted, it's no surprise that insects are the fastest-growing population in the world. And the king of the survivors is the most loathed of them all. La cucaracha. Even when a cockroach's head is cut off, it can still live for 9 days. With its limited circulatory system, the body needs little or no blood. It can even endure without food. With traits like these, it's no wonder they rule the world.
When cockroaches rule the Earth, I'll be looking for a new planet. When we come back, an object that weighs more than 1 million elephants. A lot more. Now that's heavy. Welcome back to Cooler Facts. Humans like building things on a grand scale. The bigger, the better. Well, we at Cooler Facts are going to supersize you. When we say big, we mean big. Like 5,700 Wembley Stadiums big.
The human race loves to build big. The world's heaviest building is the Palace of the Parliament in Bucharest, Romania. It weighs an amazing 700,000 metric tons. That's roughly the same as a herd of African elephants, 1,300,000 strong. The largest man-made structure is the Great Wall of China. It is 6,400 kilometers long, roughly the same distance as driving from Chicago to Los Angeles and back. The Great Wall also averages a width of 6.5 meters, which gives it a total footprint of about 41 million square meters. That's about 5,700 times the area taken up by the pitch at London's new Wembley Stadium. In fact, you could fit 5 Wembley Stadiums end-to-end in one of the world's biggest man-made holes, which is located in Mirna, Siberia. Measuring a whopping 525 meters deep and over 1 kilometer across, it's a diamond mine with a difference. Dangerous air currents inside the hole create a suction effect, which is so strong it has caused a number of helicopters to crash. Crashing of a different kind is something they do well in the Netherlands, where they set the world domino toppling record with over 4 million domino tiles. Lined up in a row, they stretched on for 100 kilometers. Not bad for a game that was originally invented as a math puzzle in 1120 AD.
You know, for a place that's basically a frozen wasteland of ice, Antarctica is a pretty compelling and vibrant place. Why else would one of the world's biggest research centers be there?
The southern polar ice cap may be the coldest, driest, and windiest place on Earth, but Antarctica is anything but boring. The amount of ice alone is astonishing. 30 million cubic kilometers of it. Chop it all up, and every person on Earth would get a chunk the size of the Great Pyramid at Giza. Wow! If Antarctica's ice sheets melted, the world's oceans would rise by 60 meters, everywhere. Most of the ice rests on rock. What floats are called ice shelves. Ice that breaks free becomes icebergs. 90% of an iceberg floats beneath the surface of the water. Antarctica is home to the world's largest icebergs, including the B-15A. Roughly the size of Luxembourg, it broke off from the Ross Ice Shelf in 2000. Antarctica isn't all ice. Its inland parts are covered in dry valleys. With almost zero precipitation, this is actually the largest desert on Earth. It has not rained in the valleys for 2 million years. Antarctica is actually the best place in the world to find meteorites. Dark meteorites show up against the white expanse of ice and snow and don't get covered by vegetation. But there's more than just ice and desert. It's home to blue whales. During the feeding season in Antarctica, one whale eats about 4 million krill a day, or 3,600 kilograms every day for 6 months. The daily intake would feed a human for about 4 years. Antarctica is also teeming with scientists. The ice has made it the world's biggest laboratory. Because it's been here for thousands of years, and the coverage is so deep, it tells the story of the Earth's past. If you want to know what the temperature was 50,000 years ago, all you have to do is find a layer of ice that old, then just drill a hole in it, find an air bubble, and measure the CO2. More modern ice cores are proof of a rapidly warming planet, resulting in this, the snapping off of ice shelves. In 2002, the Larsen B shelf disintegrated. At 3,000 square kilometers, this ice cube was the size of Rhode Island. But when it comes to the geological drama of the Antarctic, it was only the tip of the iceberg.
I can't believe there's a place on Earth where it hasn't rained in over 2 million years. Well, from Earth years to light years, have you ever wondered how long it takes light to travel from the sun to us? Those warming, cooler facts coming right up. Hi, I'm Kim Jake Tiani. Welcome back to Cooler Facts. Pretty fast, eh? Well, that's nothing compared to some of the fastest things on Earth, including a common occurrence that will blow you away.
In spite of what race fans believe, it doesn't take a checkered flag to identify a speed champion. It's time to rethink our concept of speed and to find it in unusual places. The most scientific measure of speed and distance in space is the speed of light. Every day, it takes light just over 8 minutes to travel 146 million kilometers from the sun to warm the Earth. Closer to home, light needs only a second to travel from the Earth to the Moon, less than the average heartbeat. A car traveling 100 kilometers per hour non-stop would require almost 5.5 months to travel the same distance. Distances in space are measured by the time it takes light to travel. NASA's Hubble telescope recently discovered a supernova in one of the closest galaxies, only 7,500 light-years away. That's just a blink in the history of the Earth. In a galaxy less far away, your body is an example of a high-speed system. Every second, your body creates and kills up to 10 million red blood cells. That's 144 times as many shares as are traded per second on the New York Stock Exchange. Now consider this big deal. A sneeze travels out of your mouth at 160 kilometers per hour. This reflex response involves muscles in your face, throat, and chest. It's an incredible force. Sneezing puts such tremendous stress on your body that it's impossible to keep your eyes open. Beards are the fastest growing hairs on the human body. If the average man never trimmed his beard, it would grow to nearly 10 meters long in his lifetime. Before stroking your chin to think about that one, some human reactions hit speeds that defy thought. Since 1982, Ernie Hill has held the record for getting a signal, then drawing a pistol from a standing position and firing a shot in 0.208 seconds. It's hard to believe, because a reaction time of less than 0.1 of a second for Olympic sprinters is considered a false start. The time between the starting gun firing and the first kick off the start blocks is measured with electronic sensors. It takes 0.1 of a second for the sound of the starter's pistol to reach the runner's ears and for a human to react to it. And there's nothing exclusive about top speeds in humans. A tiny 6mm insect known as a froghopper can jump so quickly that it generates a G-force of more than 400 gravities. An astronaut never feels more than 5 gravities to reach orbit. When the bug jumps, its leg muscles explode with a force to send it moving 4 meters per second. That's 140 times the force of a human high jumper. You don't even need legs to spring fast. There is a unique Malaysian snake that is adapted to living in the dark, and it feeds on bats. The cave racer can strike out into the air so fast that it never gets detected by the bat's natural radar system. You can find astonishing speeds lurking throughout space and nature, and sometimes even radar won't help you spot it.
So that's why snakes can never get speeding tickets. After the break, we're speeding off to a place where there's a storm raging the size of 3 Earths. We'll be right back. When it comes to our solar system, Mars gets its fair share of attention and is definitely on everyone's radar. But it can't hold a candle compared to the planet that weighs twice as much as all the other planets combined.
Showy, brash, and utterly spectacular, Jupiter is the Las Vegas of planets. Everything about it is excessive. For starters, there's its size. The 5th planet from the Sun is truly colossal. 1,000 Earths could fit inside it. In terms of mass, it outweighs all the other planets combined, ×2. Then there's this, its Great Red Spot. This storm of swirling gas has been raging for hundreds of years. 3 Earths would fit within its boundaries. Jupiter's atmospheric pressure is beyond comprehension, many millions of times greater than ours. The result? Giant swirling oceans of liquid metallic hydrogen that cover it, a gassy molten surface that will forever prevent us from landing on it. Jupiter's brand of hydrogen is unknown to us here on Earth. The ordinary variety is one of Earth's most abundant elements, but never in metallic form. In the high-pressure maelstrom of Jupiter, hydrogen turns to a solid. Because metallic hydrogen is a superconductor of electricity, Jupiter has an awesome magnetosphere. So epically huge, it belongs in the pages of science fiction. This giant magnetic bubble could engulf the Sun. If we could see it from Earth, it would look several times larger than the Moon. It also has a magnetic tail stretching beyond Saturn's orbit, more than 1 billion kilometers away. That's the distance from the Earth to the Moon, times 2,700. Jupiter's magnetic pull has earned it the reputation as vacuum cleaner of the solar system, sucking in comets, asteroids, and meteorites, ones that could do planet Earth major damage. Jupiter is so complex, it's almost its own little solar system. About 63 moons, asteroids, and comets circulate in its orbit. Officially, it has 16 moons, though likely many more. One of them, Io, is the most volcanically active place in the solar system. On its surface are about 200 volcanic caldera, giant basin-like depressions resulting from volcanic explosions. Each one is bigger than 20 kilometers. That's more than twice the height of Mount St. Helens. Io's gravity is low, just 1/6 of planet Earth's. If Old Faithful were here, it would fly up 30 kilometers. Low gravity means volcanic plumes fly fast and furious, shooting up at speeds of 1 kilometer a second, twice as fast as a speeding bullet, soaring to heights in excess of 250 kilometers. So what makes Io so hot under the collar? Tides, though not the kind we know on Earth. The gravitational fields of Jupiter raise tidal bulges in Io's crust as high as a 30-story building. As Io orbits Jupiter, the bulges move, flexing the crust and heating its interior, hence the 24/7 fireworks display. Pretty impressive for one little Jovian moon. But hey, that's Jupiter for you, always going over the top.
Well, you gotta love a planet that's over the top. And now we're filled to the top as the show that puts its own twist on science, nature, and technology comes to an end. But there are more cool facts out there, like glow-in-the-dark animals, stunning eruptions, and a river that flows backwards. Catch you next time. I'm Kim Jagtiani.